Hey everyone, so in this video what I want to do is just simply give you a brief example, or better yet, just some sort of an intuition of what limits are. Limits are basically the foundation of calculus, and every single problem that you do can be solved by using limits. Later on we'll look at derivatives and integrals, which, are just basically an extension of limits, but limits themselves aren't too complicated. Sometimes their interpretation might be a little um, inception-like, but the point is, limits are the foundation of calculus, but they aren't that hard to do. Okay. Now, what I would like to say is, for centuries, until people realized what calculus is, um, they were all trying to figure out the tangent line problem. Basically, actually, we'll solve a few tangent line problems, but I'm just gonna give you an intuition of what they were trying to solve. Was basically, how do I find the slope of something that isn't linear? So let's say I have some function. Okay, these are my axes, this is my x-axis, and this is my y-axis. Let's say I have some function like y equals 2x. Okay, if this is the case, then what are some of the points on there? Okay, so this is point 0. That would be on the line, and let's say I have point 1 over here and point 2. So at point 1, my y-axis is 1, and at point 2, my y-axis is 1. Right? So points on the line are 1, oh wait, sorry, it's supposed to be 2. So 1, 2, and then 2, 4. Right? And then this line just goes right through the origin. Now, if I ask you, what's the slope of this line? Oh, that's pretty easy. You already know that, okay, if I have some, any line in the form of y equals mx plus b, right, then the slope is just the m. And this holds true for the whole domain, the whole x value, all the possible x values for the whole equation, right? In this case, my m is 2 and my b is 0, right? So my slope for this line, y equals 2x, for all possible x, okay, is just 2. Slope is 2. What if I have something just a little bit more complicated? Okay, let's say, use a different color here. Let's say I have y equals x squared. Okay, how would I go on about calculating a slope? Okay, so these are my x coordinates, this is my y. Okay, and let's say I have a function y equals x squared. Okay, it's gonna start at, let's say, -1. I mean, it starts at negative infinity, but I'm just gonna say this. And then it goes down to 0. Alright, and then it goes back up, and then it just shoots up really fast. Okay, but at 1, the point is at the y point is 1. Okay, so these are my coordinates. This is a graph of y equals x squared. I hope you agree with that. But what if I say, okay, let's say, what is the slope of this function at the point 1? Okay, if I asked you the slope of the function y equals 2x at point 1, it's easy for you to say. It's just 2. It's 2 for every single point, and every single possible point for x. But it gets a little bit more complicated because it's not a straight line anymore. Okay, it's not a horizontal line. It doesn't have a slope of 0. It's not just like a vertical line which has a slope of infinity. Okay, it's gonna have some sort of, it's gonna be some sort of a number which you don't know how to do yet. So that's where limits come into play. And just how to calculate limits, I'm not gonna do it right now. But the intuition is that you pick some point, let's say b, which is to the right of 1, the point that you're trying to find the slope of, okay? And then you pick some point a. Okay, and what you're going to do is you're going to draw a line that intersects point A and point B. So let's say something like this. It'll be pretty steep. So let's say something like this. What I can do is I can figure out the equation of this line. Let's say it's y equals mx plus b. Then I know that, okay, the slope of this line is m. Okay, and since the point that I'm trying to find the slope of, which is the 1 over here, is somewhere between A and B, I can probably estimate that, okay, at point 1, the slope of y equals x squared is around m. But what if I want to get that estimate really, really fine, as in this right here is a big gap. Okay, I could have picked a point A over here and B over here, and then my secant line, the line that intersects the curve at 2 points, would still have a slope, right? I could still find the equation y equals mx plus b, but this time my m would not be really represented at the point 1 over here. Okay, you can see that it has a larger error. So what we basically do is that, so I'll draw it again over here. What we try and do is we get to the limit, okay? We approach the point, uh, again, it's a horrible drawing, but you'll get the idea. This is y equals x squared. We approach the point 1, which I'm trying to find the slope of, from both the left-hand side of the equation, so like from right here, and the right-hand side. Okay, and then I'll use the limits. The notation will be limit, and it'll just be known as lim, and then I'll say x approaches some value, okay, of the function. And in this case, my function is f of x equals x squared, or y equals x squared. So when I'm able to find the limit, I'll probably do a couple more things, and then I'll be able to figure out the slope of not just a linear equation, maybe a quadratic equation. Once I know how to find limits, I can even figure out what the slope of something like y equals x cubed, or sine of x, cosine of x, things like that could be. Okay, so that's pretty much the introduction to limits. Basically, we can use limits to figure out how to find slopes of lines that are tangent to different curves, not just linear curves, at different points in their domain. And all of calculus is revolved around three things. It's limits, derivatives, and integrals. If you know how to do limits, you'll have a really good time learning calculus. If not, then it's basically best in your best interest to review limits until you're careful, okay? Until you can basically just base them. So that's it for this video. Hope you liked it. Hope you got the intuition behind limits. I'll see you in the next one.